Hello everyone, today we're talking about surface area of pyramids and cones. First we're going to look at the surface area of a pyramid. Right here I have a pyramid for you. I want to take this and I'm simply going to open it up to show you the net. I'm going to then close it back up just so you can see where it came from. And then I'm going to rotate this so that you can see what it looks like from above. When we look at it from this direction, we can clearly see that our surface area is the base of the period, the base area, plus 1, 2, 3, 4, 5 triangle sides. Those are called the lateral area. The lateral faces make up the lateral area. And then we have, of course, the base area, that pentagon in the middle. If this was any other shape, we would have a different base, but then we would have more or less triangles depending on what we were looking at. So back to the original figure, and I have some vocabulary that we need to take care of. First and most importantly is that we have this height of the triangle right there. Remember when it was laying flat, in order to find the area of that triangle, we need to have the base times the height inside the triangle. We call that height L for lateral height because it's not the same as the three-dimensional height of the whole figure. So that 3D height, we use a capital H for that, and for the lateral height, we use a lowercase l. We write that in cursive so it doesn't look like a 1. The lateral height is just for the height of the lateral faces. Capital H for the whole shape, the whole shebang, the 3D height. We also have another piece of vocabulary that I never really taught you guys before. From the center right there to the side, see how we've got these little triangles that make up that pentagon in the middle? If I draw the height of that triangle right there, we usually use a lowercase a for that, and A stands for apothem, which is the height of a triangle that is part, I suppose I could say, part of a regular polygon. So we've got the apothem right there. We also have right here is the radius, and I will talk about this more in another video as well, but the radius is because I could kind of add a circle around this, and so it's the radius of the polygon as well as of the circle that would go all the way around it. So generally what we want to say, there's not really a specific formula except for base area plus lateral area, which could be written as any number of triangles that make up that lateral area. Here's an example. This is a square pyramid. So I've got sides of 4, which means this side right here is broken up into 2 and 2 on either side of this lateral height right here. And I'm given this 8 over here on the side. So I can use that to find L. 2 squared plus L squared is going to equal 8 squared. Finish my math. L is the square root of 60, which simplifies to the square root of 4 and square root of 15, simplifies to the square root, 2 times the square root of 15. So I'm going to figure out the area of my base, which we can represent as a capital B. Simply going to be 4 squared is 16. The area of one triangle is going to be base times that lateral height. Oops, that was not 12, sorry, that was 15, divided by 2, which simplifies to 4 square root of 15. Squish this up for more space. My total surface area is going to be my base plus 4 of those triangles on the side. Oops. That cannot simplify any further unless I go ahead and approximate, which becomes 61.97. And then I get 77.97. There's no units given to us, and this is a 2-dimensional measurement. This is units squared. Okay, here we have the surface area of a cone. So now we have that pyramid kind of turned into a circular shape, but it's still that circular base coming to a single point. The first thing I want to do is show you how this opens up into a net. Cone, And the first thing that I'm going to do is I'm going to squish this cone. We're going to be looking just at that purple lateral surface right now. When we're imagining the surface area of the cone, we know that we have the circle on the bottom, which is simply pi r squared for its area. The challenge is to find this lateral surface area, this purple area. So the first thing I'm going to do is I'm going to squish that purple area so it flattens out. I'm going to now turn this view so that we're looking at it from above. Look at how the edge of that cone, let me see if I can move it to the side a little bit. The edge of that cone is 2 pi r from the original circle. That was the original circumference. Wrapping it back up, unwrapping it. Stays 2 pi r because it gets bigger. It just introduces this gap. I'm going to take this area and I'm going to basically look at the area of this purple region the same way that we looked at the area of a circle initially. I'm going to segment it into a bunch of little wedges, and I'm going to open those wedges up, and then the direction of this didn't work out well. Let me see. There we go. Opening the wedges up and then folding them back in on themselves. Now, looking at this parallelogram that we've created, we know that if we increase the number of wedges, that it starts to equal a rectangle. That rectangle has a height that is equal to, look at this. This is the radius of our lateral edge. It's L. It's not the same as the radius of the bottom circle because this is that expanded circle. So this is L, is the height of that. And this base of this rectangle is half of the 2 pi r. So half of the original circumference times L, the lateral height of the cone. That's going to be our lateral area, then plus pi r squared for that bottom circle to get the entire area. So there we have it, the entire surface area put together. The surface area is the base of the cone in that circle, and then we have that lateral surface area, which is that purple side that we initially unwound. So that lateral surface area is half 2 pi r times L. Let's go ahead and simplify that. To get pi r squared, half times 2 simplifies to pi r L. And there's our final formula right there. Real quick example with that, I have this weirdly crooked cone over here. Not sure why that's crooked. Anyway, I can see that my 3-dimensional height is 6. I don't know my lateral height. That would be right here. I do know that my radius is 8, but I also know that the 3-dimensional height is perpendicular. So I'm going to go ahead and use the Pythagorean theorem. 6 squared plus 8 squared equals L squared. You might recognize this as a 6, 8, 10 pattern already, but I can go ahead and finish that and find out that 10 does equal L. So with this, I'm going to start with my surface area formula, pi r squared plus pi r L. I like always writing down my known information and my formula. Then I can go ahead and plug everything in. Pi times my radius squared plus pi times my radius times my lateral height. 64 pi, oops, not an equal sign, plus 80 pi equals 144 pi centimeters squared. We could approximate that if we were asked to round. Have a good day.